Oh my god, there's actually 13 people in here. There's 12, we lost one. Hi everyone. I'm going to try my best to look at the chat as much as possible. As long as it's not spammed by all my gods. Now the record's 13. So if we can get 14 viewers, then you're the most viewing class that I have. In case you're wondering, there's some jazz in the background. If anyone can identify where the jazz music is from, then I'll be pretty impressed. Yeah, we've only got 12. Hi, Max. That seems like Alistair said that with a very grumpy tone. Any other comments? A strange name. Tofi. Who's that? Oh, it's Henry. Now we've got 8. What's happened? Oh well. Hey Lisa. Yeah, you're really grumpy? Yeah, okay. It is early in the... Oh, it's 12. It's not early in the morning. Oh, maybe for you. Jackson left. Yeah, right. Oh, okay, Lydia, that's hilarious. You know, just because I'm behind a computer screen doesn't mean I don't take offense to things. Yeah. I don't like Weet-Bix. It looks like, on it. Yeah, shots fired. I guess I should probably do some maths, eh? I'll try and look up as much as possible. Everglades. Well. Anyway, I said we were going to move away from triangles, and we did for a little bit, but, oh yeah, thank you, yep. That was rude. I can see you having your own conversation, that's interesting. But yeah, we got to 12, now it's 11. Yeah, great. I said we were going to move away from triangles, and we did for a bit, but now we're going to move away from right angle triangles, and we're going to use trigonometry to deal with triangles that aren't right angled. So what I'm going to do is start off by drawing a triangle that is not right angled, and hopefully one that actually joins. There we go. Now I'm going to call everything like I normally would. So I'd call that A, that B, and that C. Generally when you name a shape, you do it in clockwise. And then the opposites I'm going to call little letters. So I'm going to call this one, call that A, I'm going to call that C, and call that B. Okay, and now we're done. Bad triangle, yeah, thanks. All right, now the sine rule. I guess I want to show you something. How should we explain this? I'm going to show you this 2 different ways. The first way, should we do it alphabetically or fun? We'll go fun. This might be something you would have noticed. 14, there's 14 people, how exciting. This might be something you've already noticed before, but basically, if I've got an angle in here, if I were to try and increase that angle, there's 15, well, if I'm trying to increase this angle, so in other words, if I get these two, maybe I'll just use my hands. If I've got a triangle, and I'm looking at this angle in here, there's 14, damn it. Hey Lucas, hey Lachlan. I swear, Jackson, if you start disliking, anyway, if you look at this angle in here, if I increase this angle, it actually increases this side up here. And when I decrease this angle, it decreases this side. And so I'll show you. Have a look at this triangle. So suppose I'm caring about angle A over here. Is Kai actually in here? Still nickel. Anyway, if I, so have a look at this angle A. If I start decreasing it, you can see that the line that's opposite it, so the red line, that actually starts decreasing as well. And I can show you. So this angle is 51 degrees. If I start decreasing it, so 49, 47, 46, you can see that the line starts decreasing. They might seem really obvious, but it's actually, so let me show you. So keep looking at A. As I decrease that angle at the top, I'm decreasing that line. Now, if I start moving this way, See how B is increasing and B is also increasing, so like everywhere. There is 17, oh my god. So it's not a coincidence that you might find that the ratio between this and this, it actually maintains, so it stays the same. So if I now look at this one, you can see that no matter where I move C, is that 18? That's ridiculous. You see where I move C, the ratio between this side and this side and this side and this side actually stay the same. So that's not a coincidence. That's called the law of sines, and we can generalize this and we can say that this side and this side, so the opposites, this side and this side and this side and this side, they all follow the same ratio. So in terms of, whoops, that's my emails. In terms of, how do I get back to that? This thing, I can basically say that A and little a and B and little b and C and little c, they all follow the same ratio. 17, we lost one. Why is this up and down all the time? So basically we can say sine of A, so sine of A being this angle here, the ratio of that to A is equal to sine B and their ratio, which is also equal to sine C and their ratio. So this allows us to talk about any triangle, it doesn't have to be right angled. Now, I guess we can not talk about ratios because ratios are kind of gross. So instead I can go A over sine A. So a ratio and a fraction are like the same thing basically. B over sine B and C over sine C are the same. And this is called the sine rule. Should I put a box around that? I don't really care. The second thing I'm going to show you is a little bit of a proof, and this is a bit more mathematical. I didn't delete you. Should I have done Friday's work? Yeah, probably. Oh well. Actually, last week's work has kind of nothing to do with this. So this week's work and last week's work are completely different. Alright. Let me draw another triangle. One that closes, please. Thank you. And then I'm going to chuck a line down there. Okay. I'm going to call this A. I'm going to call that B. Call that C. I'm going to call this the height of the triangle. What should I call? Let's just call this A, I guess, and call that B. That's kind of wrong, but oh well. Let me move this. Anyone know where this jazz is from? No? Okay. Okay, so if I now look at... okay. You might be thinking, why did I use sine? Like, I want you to think about why have I used sine? Like, that's just come out of nowhere. I basically said that this angle and this angle are related. Why do I use sine? Well, this is kind of my justification. So if I now just look at this triangle here, looking at this angle, I've got opposite over opposite over, this is hypotenuse here. Let's call that B. That was stupid. Let's call that A. So I've got sine A is opposite over hypotenuse, so H over B. Now also, this one, looking at this triangle here, opposite over hypotenuse, so sine B is H over A. If I rearrange both of these with H, so that means H equals B sine A, and H equals A sine B. That basically tells me that A sine B is equal to B sine A. So if these two things are equal, then these two things are equal, and that's what I've said there. And then I can start dividing stuff. So I'll move him over there, and I'll move him over there. So that's basically A sine A equals B sine B. And I've just proved the sine rule again, but using a little bit of algebra. Ava Wilson, I don't even know who that is. The chat is as loud as when we're in the classroom. 19. Anti-clockwise. Despicable Me. Baby Shark. Triggered. 74 etched music. Did you actually Spotify that? Because that's kind of funny. Okay, 19's a record. Let me write that down. Okay, so there's two ways of writing the sine rule. Now, why do we even care about the sine rule? Well, in normal trigonometry, what we care about is trying to find unknown sides. So let's try and do that. But in this case, we're going to do it in triangles that aren't right angled. And we're still going to refer to it as trigonometry. So let's go, example 1. Let's draw a triangle. Not right angled. I'm going to call this, let's do nice numbers. Let's make this 30. Let's make that 60. Let's say this is, I don't know, and let's say this is 2. Let me try and figure out what I don't know is. What technologies are being used to study these artifacts? How are they helping us understand prehistoric societies and conflict better? Anyway, now to use the sine rule, what you also need to notice is, see if I've got A and sine A and B and sine B, which is all the A's and all the B's, you can only use it if you've got, so I like drawing this normally, I like going, yep, yep. If you have all of the informations within those two circles, then you're good. If I had this, 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 and this, I wouldn't be able to use the sine rule. So you need to be able to, in this case, so I've got an angle and the opposite side. I've got an angle and I'm trying to find the opposite side. So in this case, I can use it. Now, I'll write the sine rule. Sine A, B, sine B. I guess I've got to name something. Let's call this A. Let's call this B. And I'll replace it. So therefore, x on sine 60 equals 2 on sine 30. It wasn't a coincidence I used these numbers because I was trying to make my answer look a little bit nice. I was trying to bring in last week as well. I don't know why people are talking about teeth in here because that's kind of random, but you know what? We'll roll with it. Is it because that looks like a smiley face and kind of has teeth? Anyway, I can rearrange this. So to get x by itself, I need this to go. It's divided by this, so maybe I'll times by this. So I'm going to have x is equal to 2 on sine 60 times by, what did I write 60? 30 times by sine 60, that's an email. Okay, that's equal to, this is the point where you can just type it in your calculator, which I would advise, but if you've got nice values like sine 30 and sine 60, you don't actually have to. Now let's see how well I work this out. So 2 over sine 30, that's a half, according to my table. Is that how we show our working out? Yep, that's fine. Times, now sine 60 is root 3 on 2. Should I be taking notes? Okay, 2 divided by a half. That's the same as 2, so 2 divided by a half is the same as 2 on 1 divided by a half, which is 2 on 1 times 2 on 1, which is 4. So I'm going to write 4 times root 3 on 2, which is 4 root 3 on 2, which is 2 root 3 on 1, which is 2 root 3. And I did not need to show all of that. All I really needed to do was go from here to here, or I could have just typed that into the calculator. But just be careful, because if you ended up with something like this and the answer wanted it to be exact, when you type this into the calculator, obviously 2 root 3 isn't going to, it's not going to pop up as root 3, it's going to pop up as whatever that is. So you're going to end up with a huge decimal. It's going to be hard for it to be exact. But also that's an exact answer as well. So it doesn't really matter. That's actually all I had for today. So you just need to recognize that the relationship between an angle and a side and the other angle and the other side, they are consistent. That's one way of proving that they are consistent, and you just need to be able to find an unknown side. That's it. If you're asked to, so in this case, if I wasn't given this and I was given this and it said find the unknown side, you actually wouldn't be able to do it unless, actually let's do that because that's an interesting example. Sorry, tangent. Let's call this A. Let's go with B. Let's try and find Y. Let's try and find Y. Can anyone beat me to how I'm going to find this? That would be cool. So I said before that I need opposite things. Use cosine or tan. No, sorry. I wanted to say you're close, but you're not. So I'm going to redraw the triangle. Why do my triangles stuff up every time? That's not even the same as the other one. That's Y. That's, have I got an answer yet? Sheesh, no. 30, 60, 2. I said before that I needed opposite things. So I need this and I either need this or this. I'm trying to find this. I'll keep going, okay. Or maybe I'll just write the equation first. Sine A, B, sine B. You don't have to put your hands up, you can just chuck something in. Let's call this A, and A. I'll start filling that in. 2 on sine 30. Not yet. Solve the third angle. Yes, thank you. Okay, so I can find, I need this, which means I need this. And I can find that because I know that the angles of a triangle, sum of the triangle is 180. So this thing must be 180 minus 30 minus 60, which is 180 minus 90, which is, oh my god, 90. I just said that we didn't need, that's kind of funny. I said before that the whole point of this was to deal with triangles that aren't right angled, and I've just made an example where the triangle is right angled. Oops, daisy. Anyway, that's fine because 90 is a nice number. Y over sine 90. Yeah, thank you, MLG, dub 03. Nice, yeah, thanks. Yeah, pretty insane, yeah. That's okay. I'm not that sad. All right, to get this y by itself, I'm going to move him over. So I'm going to have sine 90 times 2 on sine 30. Actually, we already know that that's 4. Equals y. Okay, sine 90. Now, what do we do when we make a mistake? We try again. Sine 90. I can never remember if it's 1 or 0, so I always just quickly draw up a unit circle. So my unit circle, sine is the y value, so that there, y equals 1, which equals sine 90. So that means that's 1 times 4, which implies y is equal to 4. Now, this wouldn't have made much sense if I ended up with sine 0, because if I ended up with sine 0, then that would suggest that two things. One, the bottom of this denominator would be 0, so it would be broken. Also, that would suggest that this angle is 0, which just means I'm dealing with a straight line, so trigonometry is also broken. I guess another reason we don't use cosine is because in this instance, if I had a 90-degree angle and I tried to use the cosine rule, then I would also be broken because this is equal to 0, because x would be equal to 0. So that's also a reason it would be broken. Now, I did want to pose the question. In this case, I did obviously use opposite and hypotenuse, but A and B also share opposite and adjacent. So what's stopping me from going ED and comparing those? So you could potentially have a tan rule. I actually don't know if that's a thing. I haven't ever researched that before, but yeah. Anyway, is there any questions about that? Is there any questions in general? Maybe I should stay here for another, it's 12:18. I'll stay here for another 3 minutes if you just want to ask me random questions or questions about this. Maybe, I don't really care. Either or. Pretend we're in class and you're just firing stuff at me. Yes, that's not a question. Why are we talking about monkeys? Oh, it's Will. Oh, hi. Sorry, I forgot. Isn't there a cosine rule? There is a cosine rule, but it's a little bit different. Don't know who that is, Max. You're not paying attention. Great. There is a cos rule. We're going to do that not next lesson, the lesson after. But it's a little bit different. I was really listening. What is this about? So you were listening. That doesn't make any sense. This is why you sit on the side of the room, Jackson. How many comments are there? Wow. Is that a Coop? Is that Cooper? So we got to 19 viewers. That's pretty. Wantsty, hasn't. Wasn't. I got it. Roasted. There's a dab emoji, and people in the year 12 class were doing that before, and it was extremely triggering. Winter time. What does that mean? Is that the song? No, it's not. That's pretty epic. That's irritating. Okay. Oh, that is irritating. Thank you so much for that, Tofi. Nice unicorn. Who is Candace? Do you guys want to see the advanced paper? Last year's HSC? Let's see if we can answer some of it. Nope. Nope. Surely there's a question we can answer. Oh, look at this. The HSC paper from last year. The good old bearings question. Show that angle APB is 65 degrees. APB says that they worked on a bearing of 35, so that's 35. Then they worked on a bearing of 100, so that's 100. Oh, this is easy. We should be able to do this. It's only 1 mark though. Someone tell me what that is. Oh, damn it. It says it. 65. Anything else? Oh, look at this. Bit of trig. What else we got? A bit more trig. A box plot? We should be able to do that. It don't make money, then it don't make sense. Mr. Ali, I don't know who that is. Look at this though, a full page of writing, 5 marks, and then you get a full page of working out. Oh, here, look, standard deviation and mean. Actually, that question before, where is it? On the table. Oh, maybe that was the paper I did yesterday. Here, look at this. Trig, and that's it. Anyway, I thought this was the sine rule. Yeah, it was. We're just having a bit of fun, Jackson. You should not have mentioned the dab emoji, sir. Yeah, you're right. What is that? Is that a chef? Didn't see what happened in that country. I'm sure it's a stitch up. So your pen that you're holding looks very nice today. It's called an Apple Pencil. Thank you. Thank you, Max. That's really yeah, elbow cough emoji. Yeah. A Debbie Downer. I actually haven't heard that before. A Debbie Downer. What is that? Is that a moon? I'm not answering that, Alex. Not going to say it. I know it's a stitch up. The chat was very explosive, but the lesson was great. Yeah. I don't even want to think about what that is, Brock. I don't want to look at that too closely. Well, I can't believe that we beat the record. 19 viewers is pretty cool. What's your star sign? Aquarius. Obama's last name is Obama. What have you heard about what happened in web? A derogatory term. I'm very disappointed, Alistair. Yeah. That does not look like an elbow bump. Maybe I'm looking at it from the wrong angle. It looks like two people bending down. Anyway. Aquarius, yeah. What are you, Lucas? How are there more viewers now? E10. Oh, really? I don't like all these digs you're getting in the video. That's not What are even the properties of an Aquarius? Libra vibes. Imagine judging people based off the month they were born in. Yeah, that's pretty funny. Surely you should know when my birthday is. You did sing it. Please stop saying E10. Like E10 fuel. This is a banger that's playing right now. If you really think you're gonna get me with that, Alex, we invented that, not you. Most compatible signs with Aquarius are generally considered to be Aries, Gemini, Libra, and Sagittarius. Wow, thank you. That's so informative. How is there more viewers now? February. It's not something to do with Spider-Man. Isn't Sir a Taurus? No, I'm not. I'm an Aquarius. Really, Lucas? No, I would play Spider-Man, but it would get banned, or the audio in this video would be muted. Ep 3, I don't know, when we can actually be next to each other and film. The least compatible are generally, yeah, right. Yeah, that's it, Alison. Independent, friendly, rational, tactless, loyal, idealistic, original, and creative. I'll take that. Tactless. Idealistic. Do you want human music next time? Because that's a banger. Do you know about? No, I don't. Yeah, hilarious. So funny. Haha. So funny. Alright. We'll go till 12:30 and then I'll call it. Having or showing a lack of skill and sensitivity in dealing with others or with difficult issues. Is that tactless? Yeah. Bacon fat. I'll look at his channel and I'll try and find something and put it on loop. Is that a teddy bear? Make a poll for what music? That's not a bad idea. That's a good idea. I'll try and make a poll in the classroom. Go see the... Not reading that. Tactless, yeah. I figured. Is that a squid? An octopus? I reckon I've been looking at this chat for longer than I actually... A 14-year-old just came 4th at the Olympics and we were here doing nothing. Sorry. I was watching the skateboarding before, and did anyone see that 12-year-old table tennis girl from Syria? That was pretty cool. How do you feel about soccer? Do you mean like the Olyroos, because they played terrible? My watch tells me I need to go for a walk. Look, I'll say you play terrible if you can't string a pass together. Cancellation of our games. Yeah. Season's pretty much over. Well, it is over. I was meant to verse Mr. Rogers, I think, last week. That would have been cool. Oops. Alright. Can you imagine missing a penalty like Sam Kirsch? I hate when people say they missed it because she didn't miss, like they saved it. It was on target. Alright, well that's 12:30. So, goodbye.